Hi everyone, I'm Meghna Thotukuri and my team members are Amni Ponnam and Meghna Basvaraju. Here we are presenting self-learning AI for board games using reinforcement learning as our AI term project. So coming to objectives, as we are developing a self-learning AI agent using a Q-learning and reinforcement models. So here we are training the agent in every episodes to perform better by giving feedback in the form of rewards and penalties. Coming to approach, as I've said before that we are using two models in reinforcement. We are using DQ and deep Q learning for optimizing the action. So here we employ with CNN technique, which is a neural network by depending on Adam optimizer. In Q learning, we are using Q table to make decisions which an agent will follow through trial and error method using Bell-Manford equation. Here mainly agent aim for the reward by choosing the best possible action. And coming to the tools, all these are the libraries which we use for our neural network models. And all these models use pre-trained data instead of starting from the scratch. So this is our training approach. And coming to deliverables, we are using Python scripts for developing our board game using two models. And those two models are Q-learning and reinforcement. And uh, in this training model files, every episode will be saved to train the agent in order to maximize the output, and the results of the models will be clearly explained through patterns. And also we are using virtual tools to present the gameplay by importing some libraries. Coming to the evaluation methodologies, here we are collecting the rewards across each episodes for better performance, and the trends will be determined through a pictorial representation. So here main motto of this methodology is to ensure that agent is making best move by getting feedback in every episode. So coming to these differences, uh, we can say that reinforcement learning model is considered as the best model because here we are using neural networks, and the main advantages of this reinforcement learning are simulate navigation and in making the best decisions and optimization task and also better performance. So about these two models, my friends will explain clearly. Over to Amni.
Hi guys, I'm Amni Ponnam. As my teammate said before, we use it Q learning and reinforcement learning. So here I will explain Q learning technique. First, we use a library called Pygame, so which is used for like Q learning agent to play a basic snake game. And next, we are using libraries like NumPy, Random, Default It, Matplotlib, Function Animation. And next, we initialize the Pygame like screen dimensions with the head, width and height 300, 300, and size of each grid cell 10 and frames per second 15. And also we use the colors like white, green, red, black, and the directions up, down, left, right. And some of the Q-learning hyperparameters like learning rate 0 0.1, discount factor gamma 0 0.9, and initial exploration probability 1 start with 1, and the final exploration probability ends with 0 0.1. And here decorate for epsilon, and some of the episodes 1000 episodes we have used. And we have set up here the pygame, like here screen equal pygame display, that all stuff. And we use the class name called snake game, so it resets the game start. And next we are using the epsilon greedy. Like the reward system follows like +10 for eating food, +1 or -1 for moving closer or further from the food, and -10 for hitting walls or itself. And also balances exploration using epsilon greedy. Start with the high exploration and gradually decay exploration using epsilon decay until reaching epsilon n. As we know that we use the episodes, so here runs episodes iterations of the game and also trains the q learning agent by repeatedly playing and improving the q table. At the end of training, plots the overall performance. And next we use it spans food at random locations, so it ensures it does not overlap the snack. And we take an action and update the game state, like how it will move the snake, check for collisions, check if food is eaten or not, and also encourage moving closer to food, and like giving a reward or penalty based on proximity to the food, returns a more detailed state representation. And here we use the some of the loops, like start with a new game using game reset, loop through steps until the game ends, and choose an action random or based on queue values, execute the action, update the queue table and accumulate rewards. And next we use the render. So render to visualize the graph like that. So first I will run this code here. So it takes time. So previously I took the screenshots of this. So I will show that one. Mm, 1 second. Here is the graph shows that it gradually increasing, but it not increasing very quickly. So it's constantly increasing. I did 200, 400, 600 episodes, 800 episodes, 1000 episodes. So um, that's why we taken the reinforcement learning. Next, my teammate will explain about the reinforcement learning.
Hi all, I'm Meghna Basavaraju. So I'll be explaining how we developed reinforcement learning. So this is the main agent, which will be, this is our main code which is going to be running to train our model and get the better result. So here we have imported few of the libraries and we have created few modules to make sure it's utilized further. So we are using a CNN model. So we are using linear QNet, and this has been developed using library called Torch. And the model CNN we are using has input layer, and this input layer takes 7-dimensional state, and we got one hidden layer, which is a dense layer, which is going to be functioning on ReLU activation, and the output layer has three neurons representing Q values for three possible actions. And over here we got a method called save, which saves our model weights. And we do have a class called QTrainer, which handles the training process using Adam Optimizer, and we are using mean square error loss for it to estimate the error. So the agent which we have created over here learns from its experience using the environment and stores the experience in its replay memory, and neural network predicts the q value for action, optimizing them through training. So this is our agent, as you could see, and this will be triggered from the train over here. So from here the agent is initialized, and the agent has the following values. So we are initializing the gains to 0, epsilon to 0, and gamma to be 0.9. and we are using memory, and this memory we are using is from the local memory, and we have set its max memory to 100K and the batch size to be 1000 and the learning rate is set to be 0.01. So after every episode, our training is set to this short memory, and later on, the depending on the values, it is also uh, written or override to the long-term memory, and that's how the weights are later on stored to the model, and we are downloading the model once it is done. And this is the process we are following to run our train our model for better results compared to what has been done in Q learning. So now I'll be running my code. So because of the memory utilization, it's gonna take some time. Just bear with it. So this is our snake game, and this is our graph which is generated side by side depending on our score, and also it's going to estimate the error as it goes. So as you can see at beginning, our scores are 0. As our model trains, the score starts increasing at one point. Just give it some time. Yeah, as you could see, it started, getting scoring 1, again 0, and again it will start increasing to 1. And our model does take pretty good time to train itself. So I don't want to take your time, waste your time further. So I'll be showing you the results, what we have saved. So I did take results after 100 training and 200 training over here. So if you could see, our model starts performing better after, you know, it starts spiking around, 40 over here, and we get better scores around again at around 90, and it does better perform as